In this question, we are reviewing Unit 1, which is from the beginning of the school year. You're being asked to solve a system of equations. There are answers where you can have no solution or infinitely many solutions. So let's check. Okay, here we have 3 equations, so it's a system. And then when they ask you to solve it, they're pretty much asking you to find what x, y, and z represents. What numbers can you plug in for you to be able to type it in into each section or into each equation, and then all of them equal and be correct. So sometimes you are given values for all 3. Sometimes that is not possible, so you get no solution. And sometimes a lot of numbers give you those answers, any amount any combination. There's a lot of combinations that could, so then you get infinite amounts, infinite solutions. So there's a lot of methods of solving this. We learned graphically, algebraically, and through the calculator. So the calculator is the method that you all chose to be the fastest and quickest. So let's practice that. We are going to use, it's called a matrix method, using matrices. So you first wanted to check that these equations are following the standard form of ax and then by and then z and then 0, or a number, I guess, a constant. So if you notice, pretty much all you need is to check that x, y, and z are on the left side of the equal sign. All of them are. So now we're going to create a matrix with the coefficients and constants that you have. So you have 1 for the x, 1 for the y, 1 for the z, and then an 8. Then you have a 3 for the x, negative 1 for the y, positive 4 for the z, 25. Then you have a 6, a negative 2, a positive 8, and a 50. So this is a matrix that was created from the system. So what you're going to do now is use the reduced row Euclidean form. It is also known as RREF. And that is the program that is installed in the calculator to get you your answers. So we're going to go to menu. We're going to go to number 7 where it says matrix. Then we're going to look for reduced row Euclidean form. So number 5. This comes out in the calculator immediately. You can either type this or just go through the process we did, menu 7-5. And then here's where you're going to insert the matrix. So you're going to press the button next to 9, and we're going to look for the matrix symbol. And it's going to ask you for number of rows and columns. So we talked about rows being just 3, 1, 2, 3, and then columns 4. And then now here is where we type all these numbers. 1, 3, 6, 1, negative 1. If you forget a negative, you're going to get the wrong answer. So be careful. All right, so now we typed everything. We're going to press enter, and then we interpret the answer. So what we want is answer to look like 1, 1, 1 diagonally. Because what this will mean is that we have 1x equals the number that's here. We're going to have 1y equals the number that's here, and 1z, the number that equals right here. So this is what you want. If you don't have it, then you have a special case. You either have no solution or infinite solution. In this case, we have 0 all the way, which means that we do not have a z, and we have 0 here. So it leaves you with the statement that you got to check. 0, 0, 0 is nothing. And then over here you have 0, so that's nothing. Does nothing equal nothing? Yes. So because it's true, it's a true statement, you will have infinite solutions as your answers. So that would be the answer for this system of equations.